All right, it's time to start. Calculating the pH of a strong acid, or calculating the pH of a strong base. This will take about 30 seconds. Here goes. HCl is a strong acid. It dissociates to make H plus and Cl minus. Watch now how nice and neat and formal I am. It's going to set up a Ka, which is equal to H plus times Cl minus over HCl. I have my concentration of my acid to start. I've just thrown 0.1 molar HCl in solution, 0.3 molar nitric acid in solution. I have no protons to start, no hydroxides, no chlorides to start. That's the strong acid case. I throw it in, and what happens? Well, by definition, all of this dissociates. All of it. And what's formed is stoichiometrically equal amounts of the proton and the chloride. So, at equilibrium, I have no HCl left, by definition. I have Ca of the proton and Ca of the chloride. But wait a second. The chloride is a spectator. It does not contribute at all. So that at equilibrium, I have no HCl, chloride has no effect. My proton concentration is the only thing that matters, because that's the only thing I need when I measure pH, and it's equal to the starting amount of the HCl. Therefore, what is the H plus for a strong acid? The H plus is equal to the starting concentration of the strong acid. And the pH is going to be equal to the P of the starting concentration. Well, let's do some problems. What is the pH of 0.1 molar HCl? So that's actually 0.1 molar of this going in solution. Well, I've just done the approximation that 100% of this stuff is dissociated, and I've approximated that the chloride has no contribution to the acid-base chemistry. Therefore, the H plus is equal to 0.1 molar. And the pH is equal to minus the log of 0.1 molar, which is 10 to the minus 1 molar. So watch me do my pH calculation. 1. The pH of a strong acid that's 0.1 molar is 1. Get this. When I'm doing this problem, if the first thing I did was to get rid of the spectator ion, then if I get rid of the chloride because it's a spectator ion, I'm left with the proton concentration, and that's what I'm doing right to start. The pH will be minus the log of the proton concentration here. But wait, what if I had written HCl, HBr, HI, HNO3, HClO4, HClO3? What if I had written any of those down and it was 0.1 molar? And I got rid of the spectators. The spectators are the salts of the strong acids. These are all strong acids. So every one of these has exactly the same answer. Isn't that amazing? Here I am looking at these 7 strong acids, and because they're spectators, because their anions are spectators, when I get rid of them, the only thing that is left for me to look at is that great big screaming H plus symbol, which is what I want the answer for in the first place. And so the pH of a strong acid is simply determined by taking the initial concentration of the strong acid and taking minus the log of it.